Welcome back to another video. I hope you're having a blessed day. In this video, we are going to be talking about applications of right triangles. So yes, more applications on right triangles. If you watched the last video, we also did applications of right triangles using angles of elevation and depression. This time we're going to be using a method that's called bearing. And so just exactly what is bearing? I'm glad you want to know. Bearing is the direction of motion of an object, such as a ship or an airplane. And so we use it to express like the direction that the object is moving. And so it can be expressed in two different ways. And so we're going to look at both ways that you can express bearing. The first method of expressing bearing is when you use one single angle. Anytime you use just a single angle, you always start from a north position and you measure in a clockwise direction. So, for example, this first one here is a bearing of 32 degrees. So you start with this north line right here and you go 32 degrees in a clockwise direction. The second one is a bearing of 164 degrees. So you start with this north line and then you measure clockwise 164 degrees and create your second line. This third one here is a bearing of 229 degrees. You start with this north line, you measure 229 degrees clockwise, and that's where you create your second line. The third one or the fourth one is a bearing of 304 degrees. So you always start with the north line, and then you measure 304 degrees in the clockwise direction, and you create your second line. So this is the first way that you can measure bearing. The second method is you either start with a north or a south line, and then you create the acute angle to show the direction either going east or west from that line. Okay, so for example, this first one is north 42 degrees east. That means you start with the north line and you measure 42 degrees east. So remember, east is this way, west is that way. Okay, and you still go you go in whatever direction, either east or west. That tells you whether you go clockwise or counterclockwise. So this second one is south 31 degrees east. So you start with the south line and you measure 31 degrees to the east. This third one is south 40 degrees west. So you go south, start south, and you go 40 degrees to the west, and that's where you create your second line. And then the last one is north. You start a north line, 52 degrees west. So you measure 52 degrees in the west direction. So the first one you always go clockwise, but this second method you go either east or west based on what the measurement tells you. Okay, so now let's look at some problems that involve bearings. This first example says an observer for a radar station is located at the origin of a coordinate system. Find the bearing of a plane located at the point -40 and express this bearing using both methods. Okay, so first of all, the very first thing we want to do is we want to sketch a picture. I always want to sketch a picture first. Okay, so we have an observer at a radio station that's located at the origin of the coordinate system. So I'm going to sketch if I can get the full, I'm going to sketch a coordinate system. And the observer is at the origin of that coordinate system, so here. And we want to find the bearing of a plane that's located at the point -40. So -40, that's -2, -3, -4. -40 is here. So this is where the plane is. Here's where the observer is. And so we always start, so we're expressing the bearing from where the observer is at the radar station. So for the first method, we'll start with a north line here. And then we'll have to measure, so this is our second line over here. But we'll have to measure in a clockwise direction from this north line. So we'll have to measure all the way around to here. And we know that when we go one quadrant, that's 90, two quadrants, that's 180, three quadrants, that's 270. So the bearing will just be 270 degrees. That's using the first method. The bearing of that plane would be 270 degrees. Now, if we use the second method, we can say, okay, start with the north line, but this time measure to the west 90 degrees. So we can say north 90 degrees west. That's one way. Or we can also say, let's start with the south line. Well, the south line is here. This line here at the bottom that I'm darkening. Oh, my charger. And we need to go, so start with the south line, and we need to measure to the west 90 degrees. So a third way of expressing this is south 90 degrees west. Okay, so that's 3 different ways to express the bearing of that plane. So again, that plane is located here. The radar station is here, so you're measuring from this radar station. So the first method is, if you just use one angle, you would always measure clockwise. So that would be 270 degrees clockwise. Second method is, you start with the north line, you measure 90 degrees west. The third one we have is you start with the south line and you measure 90 degrees west. Okay, so those are all the different ways you can express the bearing for this problem. Let's look at another example. Example 2, an observer for a radar station is located at the origin of a coordinate system. Find the bearing of a plane located at the point -3, -3. All right, so this is just like the last problem, except this time I'm going to sketch a coordinate system. The observer is at the origin just like before, but this time the plane is at the point -3, -3, which is here. So our plane is on this line here. And so what we need to find is, what is this angle? Either this angle or this angle, either one, it doesn't matter. So this takes us back to, we know that our XY is -3, -3. This takes us back to finding our R. That means the distance from the origin to that point where the plane is. So our R, remember, is equal to the square root of -3 squared plus -3 squared. So R is equal to the square root of 9 plus 9, which is 18. And remember, you always have to check to see if it can simplify any. And 18 is the square root of 9 times 2. So R is equal to 3. That's a 3. 3 square roots of 2. Because the square root of 9 is 3. So that's your R. So now we know our X, we know our Y, and we know our R. And so if we want to find this angle, I'll call this angle right here theta. If we want to find that angle, we can say the sine of theta. You can use cosine, either one. The sine of theta is equal to Y, -3 over R, which is 3 square roots of 2. The 3's cancel and they give you -1 over the square root of 2. If you rationalize the denominator, multiply top and bottom by square root of 2, then you get the sine of theta is equal to -square root of 2 over 2. Now that looks familiar. You should be able to look at that and recognize that that is one of our special angles. That's our 45-degree special angle. So we know that theta has to be 45 degrees because we know that the sine of 45 degrees is square root of 2 over 2. Now this one is negative because it's in the third quadrant. So before we was finding the angle from here to here. That angle from there to there will be 225 degrees because it'll be 180 plus the 45. But our angle theta, which goes from here to here, will be 45 degrees. So since we know that this is 45 degrees, then to find our, and I'm going to erase this just so you won't get confused. To find our bearing, our first bearing, we would have to start with the north line and we would go, so here's our north line. We will measure in a clockwise direction. So from here to here is 90, here is 180, and then if you add 45 to 180, then you're at 225 degrees. So our first bearing is 225 degrees. Now if we started with the north line and we measure like west or east, we will have an angle that's bigger than 90 degrees. And so remember with the second method, you have to have an acute angle. So we wouldn't be able to express the second method using the north line. Because if I went northwest, that would be 90 plus 45, which is 135. And then if I go northeast, you see you end up back west. You can't go northeast, right, to get to that line. So we couldn't use north to express the second method, but we could use south. So if we start with this south line here, we will measure 45 degrees because this is 45 and we know that this makes a 90-degree angle. This other angle right here has to be equal to 45. So we will start south and we will measure 45 degrees west. So those are your two ways to express bearing for this problem. That is how you would express the bearing to find the plane, okay? And so that is example 2. Let's look at some more examples. Okay, for this next example, example 3, a plane flies 1.3 hours at 110 miles per hour on a bearing of 38 degrees. It then turns and flies 1.5 hours at the same speed on a bearing of 128 degrees. How far is the plane from its starting point? Okay, so the first thing we want to do here is we want to draw a picture. Okay, so let me get my pen here. So we want to start from a north line because it gives a single angle of 38 degrees. So from this north line, we want to measure an angle clockwise 38 degrees. So our plane was flying on this trajectory here. This is 38 degrees. Now, one of the things we have to use here is the old formula, distance equal rate times time. That will give us the distance that the plane has flown. And so it tells us that the plane flew for 1.3 hours at 110 miles per hour. So the rate is 110 miles per hour and the time is 1.3 hours. So we have to multiply that out, 110 times 1.3, and we get 143. 143 miles is how far the plane traveled. So I'm going to put 143 here, put a dot here to indicate where that stopped, okay? So that's the 143 on that side right there. Next thing we know is that it turns and it flies on a bearing of 128 degrees. So from here, we're going to create another north line, but this time we're going to measure clockwise 128 degrees, which would be somewhere like that, and create another line. And we know that this angle here is 128 degrees. And it tells us that this one flies at the same speed, but for 1.5 hours. So the distance here would be 110 because it's the same speed, but the time is different, times 1.5. Okay, 110 times 1.5 gives us 165. That's 165 miles. So it travels here for 165 miles. And we want to know how far is the plane from its starting point. Well, here's the starting point. So we basically want to know what is this distance right here. This is our X. Let me erase that and make that a little better. So this is our unknown. That's what we're looking for. So here's our picture. Alrighty. So now a couple things. We need to know what are the angles inside of this triangle, or at least one of them, to know what this distance is, or if we can get some additional information. So let's just see what we know. So we know we have two parallel lines here. That line and this line. Those are parallel lines because they're both north lines, right? So since they're parallel lines, this line right here, let me get my pointer. This line here acts as a transversal. It's cutting those parallel lines. And so what we know about transversals is that alternate interior angles are equal. And so our alternate interior angles would be this angle. We know that's 38 degrees. And this angle here would also be 38 degrees. So I'm going to go in and I'm going to write here that that's 38 degrees also. Okay. Now we also know, since this is a north line, we also know that this angle plus this angle creates a supplementary angles. That means they add up to 180. So whatever 180 minus 128 is, so 180 minus 128, that actually equals 52 degrees. That means this angle here, this one here is 52 degrees. So now that's important because now this whole angle is the 38 plus 52. 38 plus 52 is equal to 90 degrees. So this angle here is actually a right angle. And I'm going to do that in a different color. Let's go red. This angle in the red, that is a right angle. That is a 90-degree angle. And that helps us tremendously because we know that whenever we have a right triangle, we can use the Pythagorean theorem, which is a squared plus b squared equals c squared. Since this is the 90-degree angle, this is our hypotenuse. That is our c. So our a squared plus b squared, a squared is going to be the length of one of the sides, b squared is going to be the length of the other side, and that's going to equal our c, which in this case our hypotenuse, which is the x. So we know this distance is 143. We know this one is 165 because we use that distance formula. So in order to solve for x, we're going to take the square root of both sides. And so I'm just going to switch the sides I have it written on. The x is going to be equal to the square root of 143 squared plus 165 squared. Plug that in your calculator. If you plug that in your calculator, you actually get 218.3437657. And what we want to do is round that to the nearest whole number. If we round it to the nearest whole number, we actually get x is equal to 218 miles. They're 218 miles apart. Now, on your homework, it'll tell you what to round it to. Technically, we have, we'll just leave it at that. We'll just go by that. I was going to say, if you count the number of significant digits, we have 2 significant digits here with the time, and then we have 3 with the speed. So we have varying significant digits. Sometimes you have to go with the least amount of significant digits that's given. If we would have to go with the least amount of significant digits given, it would be 2. And so we would have to round this to the nearest 10 to get 2 significant digits and make it 220. But 218 is actually the approximate answer to the nearest whole number, okay? If you have any questions about this problem, please put it in the comments below. Hopefully everything was straightforward. Let's look at another example like this, or similar to this. Example 4, we have 2 ships leave a port at the same time. The first ship sails on a bearing of 40 degrees at 18 knots, which is nautical miles per hour, and the second at a bearing of 130 degrees at 26 knots. How far apart are they? So drawing a picture is going to be the first thing you always want to do. We're going to start with the north line. It says 2 ships leave a port. So here's our port. They leave at the same time. The first ship sails on a bearing of 40 degrees. So we're going to go 40 degrees in a clockwise position. So we know this angle is 40 degrees. And it travels at 18 knots. 18 knots, which is nautical miles per hour. So we don't know the distance yet because we don't know how long we travel. So we're just going to keep this in mind. We're going to have to use that somewhere probably. The second one travels on a bearing of 130 degrees. So from that same north line, we're going to measure 130 degrees, which will be approximately, it's going to be a little further than that. Probably about right here. 130. Well, if this is 130 and this is 40, that means 130 minus 40 is 90. That means this angle right here is 90 degrees. Now the whole angle is 130, but this angle right here is 90 degrees, which is really, really important. That lets us know that we have a right triangle here. Alrighty. And so what we want to know is how far apart are the ships after 1.5 hours. So that 1.5 hours is going to give us our distances along with the speed. So remember, distance is equal to rate times time. The rate on this first one is 18 and the time is 1.5. So we're going to do 18 times 1.5. That's a decimal right there. My screen is acting up. So 18 times 1.5 and you get, all right, that's better. So if you multiply 18 times 1.5, you get 27. So this first ship has traveled 27 miles, nautical miles. So this side right here is 27. Now the second one is traveling at 26 knots for 1.5 hours. So we'll do 26 times 1.5. You do 26 times 1.5, you get 39. So the second ship has traveled 39 nautical miles. And so the distance between them is going to be this line right here. That's what we're looking for, okay? And we have a 90-degree angle in here, which means we have a right triangle, which means we can also use the Pythagorean theorem. This side, since it's opposite, since our unknown side is opposite the 90-degree angle, that is going to be our hypotenuse again. So we're going to use the Pythagorean theorem. So a squared, which is one of the sides squared, plus b squared, which is the other side squared, is equal to our hypotenuse squared, which is our unknown side. So if you want to solve for x, you take the square root of both sides. So again, x is going to be equal to the square root of 27 squared plus 39 squared. Excuse me. And if you put that in your calculator, you get x is equal to, if you round it to the nearest whole number, you get x is equal to 47. 47 nautical miles is your answer. That's how far apart those ships are. Alrighty. That's your final answer. If you have any questions about that, feel free to put them in the comments below. Alright, let's look at one more. Example 5. We have radar stations A and B are on an east-west line, and I'm just going to go ahead and sketch the picture out as I'm reading through it. So we have a station A and a station B. They're on an east-west line. That means they're on a horizontal line together. And they're 3.7 kilometers apart. Station A detects a plane at C on a bearing of 61 degrees. So if I draw a north line here, I'm going to measure 61 degrees. Should be about right there. And then there's the plane C. Now B detects the same plane but on a bearing of 331. So if I draw a north line from B, measure around 331, it will be here. So this angle here is 331. That's this angle that goes from this north line all the way around to this line where C is on. Now, since this is 331, we know from here to here is 270. So if I want to find this inside angle, it will be 331 minus 270, which is equal to 61 degrees. So that means this inside angle here is 61 degrees. Now that's important because since this is 61 and this is the north and the east line, that forms a 90-degree angle. That means this inside angle is going to be 90 minus 61, which is 29. 90 minus 61 is 29 degrees. And so that lets us know this is 29, this is 61. 29 and 61 is 90. That lets us know that this is a 90-degree angle right here. Okay? And because that's a 90-degree angle, we can use some things we know about right triangles. Now, we don't know. In the last two problems, we used the Pythagorean theorem. In this one, we wouldn't. Okay, so what are we looking for? Let's see. Find the distance from A to C. So we're looking for this side over here. The reason we wouldn't use the Pythagorean theorem here is because we don't know two of the sides. We only know one of the sides. So in this case, what we would do is we could use either the sine or the cosine or the tangent. We want to use one of these angles, and I'm just going to use this 61-degree angle here. And so if I want to know this side over here, that's going to be the opposite side of this angle. So that means I want to use sine. Because I know the hypotenuse, which is the 3.7. I would say sine of 61 degrees is equal to the opposite side, which I don't know, over the 3.7, which is the hypotenuse because it's the opposite side of the right triangle. And so if I want to solve for x, I'll multiply both sides by 3.7. And so x is equal to 3.7 times the sine of 61 degrees. You plug that in your calculator. Because your distance is two significant digits, so you want to round it to two significant digits. So x would be equal to 3.2 kilometers. So the distance from A to C would be 3.2 kilometers already. So that's how you would solve that one. Hopefully it makes sense. If it don't, if something confused you, then please put your question or whatever confusion in the comments, and I'll try my best to clarify it if you have any questions at all, okay? Thank you for watching. Hopefully this video helped you. If it did, go ahead and hit the like button, and if you haven't already, go ahead and hit that subscribe button. Thanks for watching, and I will see you all in the next video.